It's a high-stakes international match. A crucial goal is scored, the stadium erupts and the players celebrate. But seconds later, the referee points to his ear. The goal is disallowed. The human eye saw a perfectly legal play, but a microchip buried deep inside the ball saw a micro-touch that changed everything. This is connected matchball technology. In less than half a second, the ball transmits precise data to determine goals, offsides and handballs. But this creates a massive engineering nightmare. A soccer ball is designed to be violently kicked, smashed into goalposts and compressed at high speeds. How do you fit a sophisticated sensor inside a ball and make sure the electronics don't shatter the moment they make contact? Today, we're going beneath the synthetic skin to decode the tech that's silently revolutionizing the game.
To understand the solution, we first have to understand the violence of a kick. When a professional player strikes a match ball, it doesn't just fly, it deforms. The impact generates up to 100 Gs of force. To put that in perspective, astronaut training centrifuges max out at around 9 Gs. If you just glued a microchip to the inside wall of the ball, the very first kick would instantly turn your high-tech sensor into expensive dust. So how did engineers solve this? They suspended it, literally. Inside the official World Cup match ball is a system of high-tensile elastic suspension cords anchored to the outer bladder. This keeps a tiny 14-gram sensor perfectly floating in the exact center of the ball. When the ball is kicked and the outer shell squishes, the suspension system absorbs the shock. The outer ball deforms, but the sensor barely moves. It stays safe, transmitting data 500 times per second to track its exact position in 3D space. This sensor doesn't just decide goals, it tracks spin rate. It knows exactly how fast the ball is rotating when a player bends it around a wall. In fact, that spin rate is the key to mastering the Magnus effect, the crazy physics of how soccer balls defy gravity to curve in mid-air. If you want to see exactly how players exploit fluid dynamics to bend the ball, click the video right here to watch our breakdown on the Magnus effect. But wait, what happens when the outside of the ball is designed poorly? Tomorrow, we are looking at the secret aerodynamics of the ball's skin and the infamous design disaster that changed the World Cup forever. Subscribe so you don't miss it.